In this video, we're going to take a look at three legal questions that are related to three-sum. So the first one we're going to take a look at is three-sum, which is an easier question in three-sum. And then we're going to move on to a little harder question, three-sum closest. Then we're going to take a look at three-sum smaller, which is another question related to three-sum. So if you're interested, keep watching. So first, let's take a look at a legal problem called three-sum. So this is a two-pointers problem. Basically, we're given a integer array, and we're trying to find three elements that add up that equal to 0. So in this case, we're trying to find all the combination, and we want to add them onto a list. So in this case, at the end, we're just going to return this list. So in this case, we have an example of integer array, and then we're trying to find all the combinations that three elements add up equal to 0. So we have -1 plus -1 plus 2. And we also have another combination with -1 plus 0 plus 1. And the other example will be that if the array is empty or the size of the array is less than 3, then we can just return the list, empty list, because there's no elements that we can add up to equal to 0, because we need at least 3 elements to add up to 0, right? So in this case, to solve this problem, we can use, one way we can do this is we can use a nested for loop. Like we can bring the time complexity up to n to the power of 3. So in this case, we can have a outer for loop and an inner for loop, and another inner for loop to just basically try to find all the combination from there. But this will give us a time complexity of n to the power of 3. So what we can do is we can be able to bring time complexity down, and we can solve this in a n squared time complexity by using a two-pointers, right? So the idea is pretty simple. We're going to have a pointer at the one pointer, basically just iterate each and every single element. And then for each iteration, we're just going to have a two pointers, right? So in this case, we have a low pointer and a high pointer, which points to the low and the high. And then once we have those pointers defined, we're going to get our sum, right? In this case, our sum is going to be less than 0. So we want to, just like how we did it in sum number 2, if the current sum is less than 0, then we want to make sure we bring the current sum up. So by moving the low pointer 1 to the right. So now we have the low pointer 1 to the right. We have, in this case, we have our sum, but still it's less than 0. So we want to continue to do that until we get our sum that is equal to or closer to 0, right? But in this case, we don't have any options, so we are going to move on to the next iteration. So in this case, we have a sum that is equal to 0, so we're going to add it onto our list. Then we're going to move our low and the high into the correct position, so that the low, in this case, the lower pointer, right? Make sure we get the lower pointer points to an element that does not equal to the previous element, and we want to make sure the high, the element that the high pointer is pointing to does not equal to the previous element as well. So then we're going to get a sum. In this case, is another, our current sum is equal to 0, so we're going to add it onto our list. So now I pointer points to this element right here, but we notice that this element, it does not equal to the previous element. So we don't want to have duplicate combination. So we're going to move the I pointer 1 to the right? Because in this case, if the current element is equal to the previous element, we're going to have the same combination as the previous element. So in this case, we want to avoid that. So by moving the I pointer 1 to the right. So now we have our sum, which is bigger than 0, right? So now the sum is bigger than 0 because the current pointer is equal to a 0, right? So, and the next element in this case is actually bigger than 0. So in this case, we can just break the loop. So yeah, basically, let's take a look at how we can solve this in code. So our first step is to define our base case. So in this case, if we have a situation where our current size of the array is less than 3, then we can just return an empty list. So once we define our base case, we're going to make sure we sort the array, right? Because in this case, if we don't sort the array, it will not work, right? We cannot be able to perform two pointers because in this case, to perform the two pointers, we have to have a sorted array so that we can be able to decide either we should move the right pointer closer to the left pointer or the left pointer closer to the right pointer. So in this case, of course, the time complexity for the sorting is going to be n log n. But when we do the the loop, right? We have a nested for loop. In this case, the time complexity is going to be n squared. So n squared is going to be larger than the n log n. So we're going to have to say the algorithm that we're going to use for this problem is going to be n squared. So now we have to iterate the array, right? For each element, we're going to perform 2 pointers, and at the end, we want to make sure we return the list, right? So result list. Okay, so for our base case, we're going to first have a list of list integer. Okay, once we have our list, we're going to define our n, which is equal to noms.length. And then we're going to say if n is less than 3, we can just return an empty list because we need 3 elements in the array to work with. Then we're going to sort the array. So we're going to say arrays.sort. So once we sort the array in ascending order, we're going to start to iterate each and every single element in the array. So I is less than n. So then we're going to first define our case. If the current element is equal to the previous element, we want to make sure we continue, right? So if I does not equal to 0 and noms at I is equal to noms at I minus 1, then we want to make sure we continue. So then we're going to focus on defining our pointers, which is going to be I plus 1 for the left, and the right pointer is going to be it's going to equal to n minus 1. So we have our left and our right. So while left is less than the right pointer, we want to make sure we get a current sum. So our current sum in this case is equal to noms at I plus noms at left plus noms at right. Will give us the current sum, right? So once we give our current sum, we got to decide if this current sum is equal to 0. If it is, so if current sum is equal to 0, then we're going to focus on adding that element, right? So adding that element onto our list. Okay, so in this case, we're going to create a sublist. So sublist of integer. And then we're going to say sub.add. So you want to make sure add noms at I first. And sub.add noms at left. Sub.add noms at right. Okay. So we're adding those elements onto our list. Then we're going to make sure we say result.add sub, right? So because we found our combination, so we're going to add our combination onto our result list. Then we're going to move our left pointer 1 to the right and the right pointer 1 to the left so that we can bring them closer to each other. And then we want to make sure that we are getting those elements in a non-duplicate, right? So we don't want to get the previous element equals to the current element. So we want to make sure we say while left is less than the right and the noms at left is equal to noms at left minus 1, then we want to make sure we get the left move 1 to the right. If we also for the same thing for the right, so in this case, if noms at right is equal to the previous element, we're going to move the right pointer 1 to the left, right? So we're going to continue to do that until we get to a point where we have a unique element for both left and right. Then we're going to start to move on to the next iteration. Then we're going to define else if we have the current sum, right, is less than 0, then we know that our current sum is less than 0, then we have to bring the sum up. So we're going to move the right pointer 1 to the left. And if we have the current sum is bigger than 0, then we have to bring the current right, or I should say the current sum down by moving the right pointer 1 to the left. So we're going to continue to do that until we get to a point where we have our current sum defined. So yeah, we have all the combination added. Then at the end, we've got to make sure we return our result list. So if we were to run the code and run a few more examples, so now let's try to submit the code. And here you can see we have our success. So this is how we solve this Leetcode problem. And time complexity in this case is going to be in square. So let's move on to the next problem. So now let's take a look at another Leetcode problem called 3-sum closest. And we're given basically an integer array, and we're also given us a target integer value. And we're asked to find 3 integers in the array such that the sum is closest to the target. And we want to return the sum of 3 integers, right? So in this case, we have an example, and the closest sum to the target is going to be 2, because we have -1 plus 2 plus 1, which is equal to 2, right? So in this case, we can do the same thing that we did in 3-sum number 1 or 3-sum or Leetcode 15 by having sort the array, and then we have a pointers on the left and the right, and then we're going to have a variable, right? Variable that keep track of the current gap, right? The current the gap between the current sum and the target, and we want to find the smallest gap. We want to find a sum that has the smallest gap, and we will also have a variable that keeps track of the current the sum that we have so far that has the smallest gap. So to do that, we also have the constraints here. You can see the length of the array is is bigger than or equal to 3. So all we have to do first is we're going to make sure we sort the array. So we sort the array, make sure we sort them in ascending order. Then we're going to define a couple variables. One is the gap, so the gap that we have so far, and we're also going to have a max variable. Max variable basically keep track of the minimum variable. So the minimum variable is basically keep track of the sum that has the 3-sum that has the closest to the target, or a sum that has the smallest gap to the target, right? So in this case, we can have answer, right? So we can have answer. So then what we're going to do is we're going to focus on doing the loop, right? So for each and every single element, we're going to have a low pointer and a right pointer, and then we're going to figure out for each iteration, we're going to figure out our gap, right? So in this case, we're going to have iteration, right? So, and at the end, we want to make sure we return the sum that has smallest gap between target and the sum. Okay, so now let's try to implement those. So first we sort the array, so we're going to say arrays.sort nums. Okay, so once we sort the array, we're going to first define those variables. So we're going to say gap, right? So current gap is going to be integer.max value. And we also have our answer, which is going to be, so our answer is basically going to be a 0 so far. So because we haven't found anything yet, right? So then we're gonna have our iteration. So I is equal to 0, I is less than n, so n is gonna be equal to nums.length. Okay, so and for each iteration, we're going to define our left pointer and our right pointer. So in this case, left is equal to I plus 1. Okay, and our right pointer is going to equal to n minus 1. Okay, and then we're going to have a while loop. So while left is less than the right, just like how we did it in the first one, we're going to first get our current sum. So current sum is equal to nums at left plus nums at right plus nums at I. So once we have our current sum defined, we're going to see if our current sum has a smaller gap than the current gap, right? So in this case, all we're going to do is this. We're going to say integer current gap, right? Current gap is equal to math the absolute value, right, between our current sum minus the target. It doesn't matter if you say target minus the current sum or current sum minus target, they're all the same. So what we're going to do is we're going to say if the current gap, right? So current gap is less than the gap, right? So of course, initially it's going to be the largest value. So we want to make sure we get the current, update our current gap. So gap now is equal to current gap, right? It's the current gap that we have for our current sum. And then we are going to have our answer, which is now equal to our current sum, right? Because the answer is pretty much what we are returning at the end. We're returning the answer because the answer is going to be the sum that we have, right? So once we have our sum, all we're going to do is we're going to focus on moving the pointers now. So if in this case, if we have a situation where, so let's say in this case, let's do it here. So in this case, if we have a situation where the current sum, right, is equal to the target, I guess let's just do it here above this part. This can be done after. So now we have to decide which pointers we have to move, right? So in this case, what we're going to do is this. We're going to say if current sum is equal to target, we can safe to say that we're find a element that is basically has no gap between the target and the close and the sum, right? So basically we can just return our target or our current sum because they equal to each other, right? We found our closest because the closest is going to be the element itself, right? So else if the current sum, right, is less than the target, so what we're going to do is we're going to move our pointers, in this case our left pointer one to the right because our current sum is less than the target, right? Otherwise, if we have a situation where our current sum is bigger than target, we want to make sure we move the right pointer one to the left so that we can be able to get it closer, right? Get it closer to the target. The goal is we want to make sure we try to get that current sum is equal to target. If not, we want to make sure we update our current gap, right? So at the end, we have a gap that is closest to the target, and at the end, we're going to return the sum of that. And then now, if we were to run the code, okay, so now if we were to submit, okay, so here you can see we have our result. So now let's take a look at another Leetcode problem called 3 sum smaller. So we're given it an array of integers, and we're trying to find all combinations that has 3 elements, and the sum of those 3 elements is less than the target. So in this case, we have given an integer array, and the target is 2. So in this case, we are returning 2 because there are 2 combinations that has a sum that is less than 2. So we have -2 plus 0 plus 1, or -2 plus 0 plus 3. And the other one is going to be empty array, right? So in this case, if we have an empty array or an array that has a size of less than 3, then we can just return 0 because there's no elements that we can work with, right? So in this case, the goal is we want to solve this in a n squared time complexity. So to solve this using an n squared time complexity, we're going to use 2 pointers. So to solve this problem using 2 pointers, we're going to have a pointer that points to the outer for loop. The pointer is basically iterate each and every single element in the array. Then we're going to have for each iteration, we're going to have a left pointer and the right pointer. And then we're going to get the sum. In this case, our current sum is 3, right? So in this case, 3 is bigger than or equal to the target. So we're going to move our right pointer 1 to the left so that we can bring the current sum lower, right? So now our left pointer is going to point to, the right pointer is going to point to here. And then we're going to have a sum that is equal to 1, right? So now our sum is equal to 1. 1 is less than the target. So what we have to do now is we're going to get our counter plus counter itself plus the, so counter basically equals to counter plus, right? We're going to have our counter basically keep track of the combinations, right? So basically counter now is equal to the right minus the left. And the reason why we do right minus left is because in this case, because we know that those combination between the left and right is also valid because we can move the right pointer 1 to here, right? So if we move the right pointer 1 to here, we still have a combination. So -2 plus 0 plus 1 is also less than the target, right? So in this case, we can safely say that all the elements that are between left and right are also valid. So we can say counter plus equal to right minus the left. And then we're going to increase the left pointer by 1 so that we can move on to the next iteration. Or I should say move the left pointer 1 to the right. so that we can move on to the next combination. Now we have -2 plus 1 plus 5, which is bigger than 3, right? So we're going to move forward. So we're going to move the right pointer here. And in this case, we have a 2, right? So plus 1 plus 3 is 4. 4 plus -2 is 2. So 2 is less than target. So we can say that we can increase in this case, we can get the counter, right? So counter is going to be counter plus equal to the right, right? The right minus the left. In this case, it's just 1, right? So we're going to have the counter plus 1 pretty much. And then we're just going to continue to do that until we get to a point where we have iterate each and every single element, right, in the array. So now let's take a look at how we can do this in code. So to do this in code, first, our first step is to sort the array. So we want to make sure we sort the array in ascending order. Then we're going to iterate each and every single element and then trying to find the 3 sum. So we're going to define our counter, of course, and then we're going to find our 3 sum combinations, right? So all the combinations. So first we're going to sort the array. So it's going to be arrays.sort nums. So once we sort the array, we're going to define a counter. And then for every single element, so we're going to have n is equal to nums.length. And then for each iteration, at the end, we're just going to return the counter. So for each iteration, we're going to have our left pointer, which is equal to I plus 1. And the right pointer is basically equals to n minus 1. So in this case, what we're going to do is we're going to have a while loop. So while left is less than the right, we're going to get our current sum. So current sum is equal to nums at left plus nums at right plus nums at I. So in this case, if the current sum, right, is if the current sum is less than the target, if it's less than the target, we can just move the, we can just get a counter plus equal to right minus the left, just like what I talked about. Then we're going to move the left pointer 1 to the right. Otherwise, we have our current sum is bigger than or equal to target. We're going to bring the current sum down, right, by moving the right pointer 1 to the left. So we're going to continue to do that until we get each and every single element, and then we get all our counters. We get all our combination added to our counters. So now let's try to run our code. Okay, let's try to submit the code. Okay, so here you can see this is how we solve this Leetcode to 3-sum smaller problem. So the time complexity in this case is going to be n squared. So n is going to be the number of elements that we have in the array.